Today we are going to speak about the Manhattan tourist problem. So we are in Manhattan on the top left in the blue circle, and we have different sightseeing to visit. We have Carnegie Hall, we have Tiffany, we have the Sony building, and we have the Chrysler building, furthermore. And we want only to go east or south and visit the maximum number of attractions. This is a way to represent the same problem in which all attractions have the value 1. Now I'm going to change. I'm going to give to each arc in the graph a different value. For example, this one is the value 3, this one is the value 2, this one 4. Now, what is the Manhattan tourist problem? It is to find the longest path in a rectangular 60 grid. And later, we will see similar problems even when the grid is not rectangular. So, as usual, we speak about input and output. The input is a weighted rectangular grid, and the output is the longest path from the source to the sink in the grid. So, we are going to remember what is a greedy algorithm. A greedy algorithm is an algorithm that selects the best short-term solution. So here I'm at 0. I can select between 3 and 1. Why I select 3? Because it's more than 1. Here I can select between 0 and 2, and I select 2. Here between 4 and 2 I'm going to select 4. Here between 0 and 4, 4 again. 2 and 2 I select 1 randomly. 3 and 2 I select 3, and we go forward. We could have even irregular grid, and the problem will be the same, only changing the name of the grid from a regular to an irregular grid. Now, which kind of connection do you see between the Manhattan tourist and the lineman game? I'm going to show you later in the next slide how can we represent in a grid a sequence alignment. Okay, we have an alignment between the two previous defined sequences, AT GTT ATI and ATC GT CC, and I insert gaps in locations where they will optimize the score of alignment. So we're going to start. The first one is AA, so it's a good alignment, it is a diagonal. And it's the red one because it's a good one. The second one is TT, and it's again a good alignment. The third one is gap fill. I have a gap, so I'm not going diagonal, I'm going horizontal. Why horizontal? Because I'm getting a C, but I'm not getting any letter from the other one. After I have GG, diagonal, TT, diagonal, T gap, I have T, and I have a gap. So I'm going down because I have T gap here. AC, this is a diagonal, but it's not going to be red, it's going to be purple because it's the wrong one. T gap. And AC is another diagonal. So I can represent in this way that alignment. This is a different alignment. And in this alignment, I can see A gap, I'm going down, T gap, I'm going down, GA, I'm going in diagonal, TT, I'm going in diagonal, it is the value of 1, TC, I'm going in diagonal, but it's not a good value, gap G, AT, TC, AC. Okay, this concludes. So, now we are going to see how to find a Manhattan graph with the longest common alignment with the longest common subsequence. I'm sure that this alignment is going to pass in the red arrow that are very easy to identify because are the one in which the column and the row are identical. AA, TT, TT, GG, and going forward. These are the only positive arcs. In the next class, we are going to solve or describe a problem called the change problem. The change problem finds the minimum number of coins needed to make a change. So, as an input, we have an integer, money, and an array of positive integers. And as output, we have the minimum number of coins with the specific denomination. And we are going to discuss about it in the next class. Okay, we come back here.